So, in the last video, we actually saw how we can make our character attack, and let's maximize this a bit. And now we will actually make him, we will add behavior for his attack, as you can see here that he's actually shooting. Now he doesn't do any damage because I want to keep this stuff separate so that we can use our AI and keep it modular. And the other thing we're going to do is when I get out of his sight, you see he's in chase state, and then he turns into search state. And now what he does, he looks around positions, and of course he looks for us. Now of course I've toned down his sight so that we can exaggerate a bit this stuff and we can see, okay, and so that we can see and debug its behaviors. And if he sees again, then he's going to reset his behavior. Now, to make things a little bit more interesting, we're also going to add hiding spots. Now, I'm pretty sure you can guess what kind of hiding spots these are. Now, I cannot hide exactly my character under a cardboard box right now, okay, because we're not doing behaviors for our player, we're doing behaviors for our enemy AI. So, I'm going to go out of his sight so that he can start chasing me. And right now he has, to better visualize this, let's unmaximize it, and let's put our console over here. And now whenever an enemy is losing, he does not have a target, has a target, and then he loses his target, we're going to make a system that's going to actually decide what behavior to do. So you see, he can go and decide. We're going to separate in two behaviors. One will be to search on positions around his, to search on areas around him, or to search on points of interest around the map. In this case, the point of interest that our enemy can search will be the cardboard box, and we can see how we can actually make him go into search positions. And all this is we can set it up by a simple by changing a simple float. So if I go to the enemy AI, we will create a threshold, which is this, which is the decide behavior threshold. And if I put this to 10, right now it was 50-50. I'm going to put this to 10, and I'm going to make him decide. Now, since this is 50-50, right now it will always decide to go and search for the player around his positions, around him. The positions are random, okay, but it's not just a random changing some random positions into his own position. We actually sample positions in the navmesh around our player, and we take that as positions we want to go, and we also want to search, okay. And the other thing with the hiding spots is we actually create you can say it's a spherical collider. It's not really a spherical collider, it's an overlap sphere, and we put in the list possible hiding spots, and we search inside that list, and we tell him to go and search those hiding spots, okay. Now, even if a character was hiding inside a cardboard box, or it wasn't, it's a story for another time, okay, and of course another part. Now let's see this. I think we're pretty much ready to start. Now, the only thing that we are going to create something new is just a simple script called hiding spot, okay, and you can see it's still on the initializing phase. we're not going to change anything today in this script. Okay, and my hiding spots are a simple model that also have. Now, you don't actually need a navmesh obstacle. You make it static, or even if you do not make it static, you will not going to need a navmesh obstacle. Okay, I'm just having the there, so I will not rebake the whole navmesh again. Okay, now, but you must have a box collider and the script hiding spot, otherwise there's no way to tell that this is actually a hiding position. Okay, and this is all we have to do for the hiding spot. Now, but before we go into the search behavior, we're going to actually create the attack behavior. Now, for the enemy's attack, the only thing you need is to add a particle somewhere inside his gun. Okay, and we emit it when we want from the from the inspector, from the script. And I've also added an audio source with sound effects. Okay, and we call that just for a little bit of flair for for the videos. Now, the way we had the scripts from the previous videos, from the previous parts, the easiest thing to do is to actually create the attack behavior, the actual attack behavior. But before we're going to go even that, let's take care of the changes I did on the character stats and the changes I did on the player control, which is of course controls all the movement. Now, one thing to note is that the little jump that the enemy does when he's going to attack, okay, this little jump is because the animation, his stance is about half of what the actually aiming is. Okay, and when he fires, because I do not have a crouching animation, I cannot blend between them. Okay, and the fact that these are generic animations means that I also cannot use an avatar mask, and put hands on an upper layer. Okay, so keep that in mind. It is nothing. If you use other animations, you will not have this problem. Or if you use humanoid animations, okay, there are things you can do. So let's forget about that. Let's go to the character stats. And over here we've added the public boolean shooting on the previous part, and stop moving, run, and that was all. Yeah, so let's see the player control, if we did any changes, and I think that we actually did not do any changes over here too. So let's go to the enemy AI. Let's tackle the attacking first. Okay, we're going to need some variables if we are going to actually shoot, when we are going to want to start shooting, the attack rate, so how fast if you fire one, when the next time you are going to fire, what it will be. Okay, shoot rate is, we're actually deciding at random how many times he's going to shoot towards our player, and the shoot rate is, if he is going to shoot 3 times, how fast this 3 times is going to be. Okay, now since he has a rifle, I guess something like 0.3 is pretty fast enough. Okay, the internal variables and the particle system that we are going to actually send the muzzle fire. Now we're going to return in a bit to see all the searching variables. And I've also created an audio source. Okay, and I drag and drop it, or I do not drag and drop it. I simply search get component children. Since I only have one audio source, I do it that way. So and of course on AI states, I've also added the search in the enums. Okay, so I've created one more AI state, and then on attack behavior, if you remember, we were calling the attack behavior function, which was simple, which was a pretty bare function in previous videos. So with that in mind, let's go find the attack. Alert behaviors. Alert behaviors. We do not have anything new. We're gonna see that in a bit. Target available, as target, site recast, attack behavior. So, if we are not start shooting, if we are in this function, but we have not started shooting yet, we see if we can actually see our target, okay, with the functions we did on the previous videos. We look towards the target, okay, we call the function that we had created to rotate our enemy to look towards the target. Okay, right now we do not want the target's position hard-coded. We know the last known position. Okay, since we can see the target, the last known position will be the same as our players. Okay, we say to the character stats we are aiming, so it plays the aiming animation. We take the attack rate and we add by time.delta time on. If the attack rate is the internal attack rate is greater than the attack rate we want, okay, we start shooting. We reset how many times we shot, and we create a random range between 0 and 3, okay, of how many times we're actually going to shoot. And these variables are down here. Okay, I forgot to add them, to cut and paste them in the up. Okay, so how many times shot, how many times we want to shoot, and we reset the internal attack rate. Now, if we cannot see the enemy, our target, we are not aiming anymore, and we call the AI state chase behavior. So, if we are not starting, if we are not starting shooting, we see what we did. If we actually are shooting, we call the other function that is called shooting behavior. Now, in shooting behavior, we do not care if we are watching the target or not. We are going to shoot. Okay, that way, even if the player runs behind cover, we are going to keep shooting. So we are going to shoot the cover. Okay, it's going to look a bit more realistic. Now, on shooting behavior, if the times we shot is less than the times we actually want to shoot, we take the shoot rate and we add by time.delta time, and then we say if the shoot rate, the internal shoot rate, is greater than the shoot rate, we emit one particle, we play once the audio source, okay, we say to the character stats we're shooting, so in turn it plays the animation that it actually shoots, and this should probably be over here. Okay, so in player control, inside handle naming, add a check if the character stat is shooting, okay, and play the set trigger to shoot, so it plays in the animator the actual shooting animation, okay, and then make it false, so we know that it's going to play once. We add to the time shot, okay, we shot once, so we add it, and then we reset the shot rate, and this will loop, and it will fire again and again until we reach the maximum times we want to shoot. Okay, else we're not shooting. So when we fire everything, it's going to reset the shooting and it's going to return to this if statement and do all this stuff again, and then shoot again until your player or the enemy is dead. Okay, and of course this is pretty simple right now. We're going to see some more advanced behaviors for combat specifically on a later video. Okay, but you see the way we created all our behaviors from the previous videos. Okay, we actually can see, we can create it like this. It's pretty simple to create new behaviors, to add stuff. And of course, there's nothing stopping me that creating, calling this function, creating another behavior specifically for combat, like the way we did on when the enemy is alert. Okay, like the way we did with the alert logic. Okay, and calling this function, so we can this way we can stack up on behaviors and logic. So if he's shooting and he also wants to throw a grenade or anything like that, we can do it pretty easily. Okay, our main goal over here is to expand this system so something we can reuse. Now let's go to the meat of this video, which is the searching behavior. And let's go to chase behavior. Okay, we created in the previous video. We saw, or let's better yet see the searching variables we're going to need. We need a variable to know if we have decided what to do. Okay, if we have decided the behavior, we need a variable to help us decide, or pretty much the rate between what we're going to decide. So if the decide behavior threshold is equals to 5, that means there is 50-50 chance of deciding one thing or the other. The alert multiplier is how fast, how slow the decreasing the alert level is going to be. Okay, because if he has seen an enemy who's shooting him, okay, his alert level is going to decrease slower than if he just saw somebody, doesn't know he's an enemy yet, and he gets away. We need two lists. Okay, one to store the possible hiding places, which is the other points of interest inside the level or near where the enemy is, and the other list is a list of vector 3, which we save positions around, we sample positions around the unit. Okay, we need booleans to know what we're going to do, if we are going to get possible hiding positions, if we have populated the list of positions. Okay, if we are going to search around the unit for positions, if we have created these positions, we are going to search the index between those positions. Okay, so he's going to go one or the other. Okay, and then so when he reaches one position, we know to go to tell him to, we can tell him to go to the other position, if we are going to search on hiding spots, and the target hiding spot. This will help us on later videos, or when you're going to make him search at the hiding spot. Okay, you want to search if in that hiding spot there is somebody hiding. Okay, and this will going to help us that way. So let's see on AI states. Okay, I set on patrol, I set the alert multiplier to 1. Okay, on the new state we're going to create on the search, I set the alert multiplier to 0.3. I've also called the target available function. If you do not call this inside over here, even if the player runs in front of the enemy, then he's not going to see him. The decrease alert level, because when he's on search mode, I also want to decrease his alert levels. Okay, but I want the alert levels to decrease slower than what the decrease level is on patrol. Okay, so we have the alert multiplier over there. Okay, and we call the search behavior. Let's see the new, we create the new function that we're calling the AI state search by invoking this function. Okay, we change the AI state to search, we reset the target, so we do not know where the target is, and we reset the other variables that we also reset in each function, each different function. Okay, it has target, attack. Then let's close this. decrease alert levels. Okay, if character stats alert level is greater than 0, we take the alert timer and we add by time.delta time, but this time we also multiply it by our alert multiplier. So when it's on normal decreasing, the alert multiplier is 1, is going to decrease faster than when it is on the search behavior. Okay, and we continue the other stuff. So if this is 1, okay, we also multiply it by 2, so it increases, it decreases slower than actually the alert timer increases. Okay, and we also when we decrease it. If the character stats the alert level is 0, okay, that means we can, and the AI state is not the normal, which the normal is the patrol AI state over here. We change the behavior to AI state normal. Okay, and resets all our AI and goes back into our loop. So we saw the decrease alert levels. Let's see. Let's do some changes on the chase behavior. Okay, over here we had all the stuff we did in the previous video. Now over here we had something else. I think it was a debug over here, but anyway, when he was seeing an enemy, the enemy got away, so we were chasing around him. Okay, we reached the last known position, but right now we didn't have anything else to do. So we do a check to distance from the target position we're going to go. Okay, and we do it this way. And if that distance is lower than 2, or whatever you want to have over here, we have the timer until we change its behavior. If we do not add the timer, it's going to do changes. It's going to change the behaviors instantly, and that's not. It doesn't look realistic, pretty much. Okay, so we create the timer until we call the new behavior. Now, even though we have a delay inside our invoke over here, so I could just put the delay over here, but anyway, it's not wrong either way. Okay, so it doesn't even matter. But inside, if the enemy was inside over here, okay, and he sees a target and he still hasn't called the invoke over here, the coroutine, that means that it's going to actually because it's going to change the behavior because he wants think of it like putting inside the thread or whatever you want to call it. Okay, you want to do something, but you'll say you'll do it in 5 seconds. If your state behavior changes before the 5 seconds passes, when the 5 second passes, is going to go to the AI state search behavior instead of the AI state attack behavior. So anyway, this way you know that you are calling the correct behavior. Okay, we call the AI state search. We see what the AI state search was, and in turn we call this function, the search behavior. The first thing we need to do is to actually decide what behavior we're going to run. Okay, so if we haven't decided the behavior yet, we want to create a random value between 0 and 10. Okay, 0 and 11 is going to give us a value between 0 and 10. And if the random value is lower than desired behavior threshold, it's going to search in positions around the units. Else, it's going to search in hiding spots. Okay, we have decided the behavior, so on the next frame is going to come into this function. It's going to go in here is going to go inside this else statement. Okay, let's see first the search at positions, and it's a little small, as you can see. So if we are to search at positions, if we have not created search positions yet, okay, we take our list and we clear it. We clear our list. Okay, so we clear all the positions we had from a previous frame or from a previous instance that we called that we're going to search in positions around the unit, and we create a random value for how many positions we actually want to take. So I have it over here between 4 and 10, so it can randomly take positions from 4 or up to 9, and because in 10 it's going to then up to 9. Okay, so you can of course change that for how many positions you want to go, and then we say with a for loop, okay, integer I equals 0. As long as the I is lower than a random value, we add to it. So we need to offset the X and the Z. Okay, and the random positions I want to take is between -10 and 10. Okay, we need to create our original transform position. So we store that over here, and from our original transfer position, we add the offsetted X and Z. Now of course this is completely random. Sometimes by random it can also return us two positions that have the exact same value. Okay, so there are other ways to create random positions. Okay, this is not a tutorial for random positions, of course, so you can expand this to whatever you like and however you like. So as I was saying, we create a random position near the player. Okay, offset it from our player. We do not add to the Y because it's going to go up and down. You might want to add that, but probably the level is going to be pretty much around your unit. Okay, so the Y is probably going to be the same with what the Y has. Now this way though has a little bit of problem. If the unit is far away, so if you see the navmes is over here, so if the unit is over here or even over here where he is, and you see that inside over here there is not even a navmes. Okay, so we cannot, if we take a position over here and it's pretty far away than the edge of the navmes, it's going to either return an error or it's going to make our character just sit there and do nothing, and we do not want that. Okay, so we actually need to sample the position. So we create a navmes hit, which is similar to the raycast, but it only works upon a navmes. So with that we're going to create a sample position. Okay, we're basically doing a raycast but on the navmes. So we say if navmes dot sample position, the origin position is this, the one we created, we outhit it. Okay, the radius is you need to think of this as a circle. So you have the navmes over here and we say sample position over here. Okay, it's going to come do a raycast until it can find this position. I don't know if it's going to actually do it over there, but it's going to create it near the... So it basically goes into a position on the navmes and creates a sphere. Okay, and creates a sphere. Depending on the radius that we put over here, I have it on 5. That means it's going to come and create a radius of something like this, and inside, now I don't know it's exactly like this because this is pretty much, and this takes from the scale of this, so it might not be that big, so but you can play the values. Okay, so basically what it does is if that position we're giving him is from a threshold like this, is the nav mesh pretty much touching anywhere over here. So of course, if this was the position, you could see that the nav mesh touches over here. Okay, pretty simple. Okay, and then we need to also pass what areas you can also walk on, and in our case I'm put him on the nav mesh all areas, and then we add that position into with that if it hits. So if we know we can find the position near that point, okay, we have sampled the position, so we add it inside our list. Now we also need to check this runs, the for loop runs, but it doesn't mean that all of the positions is going to be on the nav mesh, or it doesn't even mean that we're going to actually have a position that is inside the nav mesh. That means that our list is going to return if there's no position. That means that our list is not going to be populated, so it's going to be an empty list. So we need to check if we have at least one position inside our list. Okay, and if we do, then we say we reset the index search position at first, so it goes to the first one. Okay, then if we have at least once, then we say we have created the search positions. Okay, so the next time it will pass this frame, it will not come inside over here. It knows you have positions, so it will come over here. So we have positions. Let's see what we do over there. We have a target position, which is the first index, the one we pass on the index search position. So the first time is going to be the first one in the list. Okay. Now you might not want the first one. You might want to sort your list before going the first one, so your enemies is going to go to the first position they're going to go. It's going to be the closest one to them. Okay, you might want to make whatever else you want. Now on Commandos I felt it was pretty random. Okay, and if you think about it, the way you will go if you're searching somebody, I don't think it's going to be too much of precise movements. Okay, so I guess I feel that works for what I'm going to do. So I have a debug log so that we know we're going to position. We say to the character stats, move to that position, and we have target position, and then we start checking from the distance for distance point, the distance towards that position. Okay, if the distance to that position is lower than 2, we actually create a random value again, okay, between 0 and 10, and if we are going to reset the decide behavior, or if we are going to continue running through a list of positions, okay, it's going to be redecided again over here. Okay, so if the decide behavior is false, it's going to turn false, then it's going to run all this, where pretty much it's going to go directly again over here, and it's going to try and redecide if you have if you're going to search on positions around unit, or if you're going to search in hiding spots. Okay, now of course you might not want that. This is all completely optional, of course. So let's say that you decide to continue on looking towards positions around the player. Then we check if we are actually if we have more positions to go to add. Okay, and if we do, we wait till the behavior passes. Okay, we add to the index search position. If not, we also wait again till the new behavior timer passes, and then we say index search position equals 0. Okay, and we go back to the first search position and we set the behavior timer. Now of course you can say that whenever you run out of positions, then you can say go and search to the hiding spots. Okay, this is all completely up to you what you want to do. Okay, AI is something everybody pretty much has to decide by himself what he's going to put inside his list. Okay, or pretty much your game designer anyway. So let's see the search for hiding spots. Okay, if the unit decided that he's going to search for hiding spots instead of positions around him, if you haven't populated the list of positions around your player, around your unit, okay, we clear the list of possible hiding places, and we want to take all the colliders we have around us. And the way we do that, we create an array of collider and we say all colliders, and then we call physics.overlap sphere, just like having a sphere, a trigger sphere that that is a sphere pretty much, and you just like using on trigger render, but we use it only for one frame and we call it this function. Okay, transfer position, which is the origin, and the radius of the sphere. Okay, so we have all the colliders around us, but we need to check if those colliders are actually hiding places. So we make a loop and we say for every collider that we have inside our array, we check if the collider has a component of hiding spot, which is the simple script. Now you could add a tag instead of the script hiding spot. Okay, but we're going to reuse the hiding spot script later, so pretty much it works better this way for us, for what we're going to do right now. Okay, so it checks if the collider has a component, the transfer has a component of hiding spot, and if it does, it adds it into the list of possible hiding places. Okay, and then you say populate the list of positions. Now, if you have actually populated the list of positions, but keep in mind that doesn't mean you actually have a hiding spot. If you have populated the list of positions, the boolean is true anyway, but you haven't you at least have one position available. Okay, so the possible hiding place.count is greater than 0, and you do not have the target hiding spot, so you have your list, but you haven't decided on what hiding spot you're going to search. And this way we do it, we say another random value, but this time the range we're going to have is equals from 0 to whatever length our list has. Okay, so possible hiding places.count, and then the target hiding spot takes a random hiding spot from inside our list and goes and searches there. So else, if we have a target hiding spot, we say to the character stats go to that position. We debug it so that we know that he's actually doing that from the console. We check the distance to target, and if the distance to target is lower than 2, we wait till we start the new behavior. Okay, and we say we do not have populated the list of positions, a target hiding spot equals null, we have not decided a behavior yet, and change and reset the time new behavior. So if he finds a hiding spot, it might go it's going to return back over here again, and it's going to redecide against once more which of the two behaviors is going to act on. Okay, now the last thing we are going to actually need is if we have populated the list of positions, but it doesn't actually mean that we have hiding places inside our list. So on else if, we're going to add another else to the bottom of this, and we're going to say no hiding spots found. So we cancel that search and we search that position instead. So instead of saying decide behavior equals false, we simply say, we turn this on, we say search at positions, and we reset all the other things we have for this behavior. Okay. Now it's actually not that hard. It's not that complicated if you think about it. Okay. We have pretty simple if statements and pretty simple function. Pretty much basically for loops and list we have over here, and some if statements, okay, and some random values. That's all there is to it. Okay, I don't think you're going to have a lot of problem. Now of course these are not a beginner tutorial, so you probably shouldn't be having any problem anyway. And that pretty much concludes this part 2. On the next part we're probably going to see some more attack behaviors. We're going to see some advanced combat behaviors, okay, so that he's not sitting just like that and keep shooting all the time. So we're going to make it something more interesting to look at and to play with. Okay, and let's see once again. Let's start this to console. He's on search. He's searching in positions around units. He's going to that position. He now decides that he wants to search in hiding spots, so he's going to a hiding spot. And now he's going to position, going to hiding spot. Now he goes to it both ways. Okay, and when his timer, his alert level goes into 0, now later on we're going to put, making our character making noise when he's running, and all cool stuff like that. So it's going to be pretty much more interesting. Okay, he's chasing us. As I said, his view is pretty much it's lower than it was going to be on an actual game, so that we can debug all this stuff. Anyway, now keep in mind that it doesn't actually does this. Doesn't mean that this is the latest one, because we have. So with that, we're going to end this video over here. If you like this video, don't forget to subscribe, like, and all the other cool stuff. Check the description for more stuff. If you also like to continue making these videos, then you can support me, because all this stuff take time, take work, and it's time I could be doing something else. Okay, if you want to support me, you can do it either through Patreon, where with $5 or more you can get access to a Google folder where I have all the scripts from all the videos, and that is about more than 80 videos. Okay, so just $5. Or you can, if you like a project, you can buy directly a complete project with all references and scripts and all that stuff set up. Okay, and you can buy that from Gumroad. This project is also there. Okay, so I'll see you next time.